You are tuned to Iri-e-learning, and I am your host, Teacher. In this atomic structure lesson, we will look at the diagrammatic representation of atoms. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to define mass number and atomic number, interpret the notations used for representing elements on the periodic table, deduce the number of subatomic particles for different atoms on the periodic table, and draw atoms with atomic number 1 to 20. We will begin with a recap or review of our first lesson on atomic structure. Keep in mind that the atom is made up of smaller units called subatomic particles, and these subatomic particles are namely protons, neutrons, and electrons. And remember that the protons and the neutrons exist in a central dense region called the nucleus. Note, in an atom, the number of protons is equal to the number of electrons, and the reason why the atom is electrically neutral. So now we can take a look at how atoms are represented on the periodic table. Here we have a standard periodic table that you would get for examination purposes. And one of the things you will notice is that the atoms or the elements are listed in rows as well as in columns, but we're not interested in that right now. All we want to do is to take a look at how each atom is represented on the periodic table. And you will notice that you have a symbol for the atom, and then there are two associated numbers, one written to the top and one written at the bottom. So what we're going to do is to explain what these numbers represent. So we're using phosphorus as an example. It has a number to the top, which is 31, and it has another number to the bottom, which is 15. So the number to the top of the symbol is called the mass number. So the mass number for phosphorus, which has the symbol P, is 31. And the mass number gives us some very important bits of information. It actually tells us the number of protons and neutrons, the total number of protons and neutrons in the nucleus of the atom. And the mass number is denoted by the symbol A. The number to the bottom is called the atomic number. And in the case of phosphorus, the atomic number is 15. Now, the atomic number also gives us some very important information about this particular element. And the atomic number is actually the number of protons that are found in the nucleus. So it only gives the number of protons. And the symbol used to denote atomic number is Z. Sometimes it's also pronounced Z, depending on where you are from. So for emphasis, just remember the atomic number denoted Z is the number of protons in the nucleus of an atom. But of course, if we know the number of protons for an atom, we automatically also know the number of electrons in that atom, because the number of protons equal to the number of electrons in an atom. Also note that the atoms are arranged in the periodic table in order of increasing atomic number from left to right. So we'll start with 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. The mass number, which is denoted A, and it's a number written to the top of the symbol, gives a total number of protons and neutrons in the atom. And so the mass number basically gives the mass of the atom. And the reason why the mass number is always the larger of the two numbers. Based on what we just learned, we realize that once we know the atomic number of the atom, automatically we know the number of protons as well as the number of electrons. So how do we determine or deduce the number of neutrons found in the nucleus of an atom? Well, we find the number of neutrons, which we will denote by the letter N, by subtracting the atomic number from the mass number. So to represent this as an equation, we can write the number of neutrons, N, is equal to the mass number minus the atomic number. Before we can begin drawing atoms, we must first determine the number of each subatomic particle present in the atom. We will practice this using 3 examples. So our first example, we're going to use phosphorus, and phosphorus has a symbol P, and it has a mass number of 31 and an atomic number of 15. Of course, we know that the atomic number tells us the number of protons, so the number of protons for phosphorus would be 15. But we also know that in an atom, the number of protons equal the number of electrons. So we also also know that the number of electrons present in phosphorus will be 15. So to determine the number of neutrons, remember we take the mass number, which is 31, and subtract the atomic number 15 from it, and we would end up with 16 neutrons. So the atom phosphorus would have 15 protons, 15 electrons, and 16 neutrons. Next, we're going to look at sodium. Sodium has a symbol Na, and notice it's a uppercase N followed by a lowercase a. Now, sodium has 23 as the mass number and 11 as the atomic number. Therefore, knowing the atomic number is 11, we know we have 11 protons and 11 electrons. So to calculate the number of neutrons, we take away the atomic number from the mass number. So we have 23 minus 11, which gives us 12 neutrons. So the atom sodium has 11 protons, 11 electrons, and 12 neutrons. Next, we're going to take one of the larger atoms and we're going to look at silver. And silver has the symbol Ag. Its mass number is 108 and the atomic number is 47. And just remember, the mass number is always the larger of the two numbers represented for the element. So we know the atomic number is 47. So the number of protons would be 47 and the number of electrons would be 47. And to determine the number of neutrons, it would be the mass number of 108 take away 47, the atomic number, which gives us 61 neutrons. So the atom silver has 47 protons, 47 electrons, and 61 neutrons. Now we're going to take a look at the electronic structure. The electronic structure shows how the electrons are arranged around the nucleus of the atom on the shells or energy levels. Electrons are arranged in a specific order on the shells or energy levels surrounding the nucleus of the atom. This arrangement of the electrons is called the electron configuration, which is denoted EC. There are four basic rules that must be followed when arranging the electrons on the shells of the atom. Note that these four rules only apply to the first 20 elements, that is from hydrogen to calcium on the periodic table. The first energy level or shell, which directly surrounds the nucleus, holds a maximum of 2 electrons. The second and third energy levels or shells hold a maximum of 8 electrons each. Now it's important to note that the rule of the third shell holding a maximum of 8 electrons is only applicable to the first 20 elements. Outside of that, the third shell can hold up to 18 electrons. The third rule states that the fourth energy level holds a maximum of 32 electrons. And finally, when arranging the electrons, the lower energy level or shells, those closer to the nucleus, must be filled with a maximum number of electrons before filling the next energy level. Now it's time to draw atoms. We will draw selected atoms from the first 4 rows of the periodic table, particularly the first 20 elements, because the electron arrangement rules we learned are specific to those atoms. Before we proceed, it is important that you understand that the drawings of the atoms are only illustrations and not what the atoms look like in actuality. The first atom we will practice drawing is phosphorus. Phosphorus is represented by the symbol P and uppercase P. In some jurisdictions, the term capital P is used. Now take a look to the left of your screen. You will see a clip showing how the element phosphorus is represented on the periodic table. This representation tells us that phosphorus has a mass number of 31 and an atomic number of 15. The atomic number informs us that the atom of phosphorus has 15 protons. However, we know that in an atom, the number of protons equal the number of electrons, so therefore the phosphorus atom will also have 15 electrons. The number of neutrons is calculated by subtracting the atomic number of 15 from the mass number of 31, which gives 16 neutrons. Once we know the quantity of each subatomic particle, we can draw the atom of phosphorus. The first step is to draw a small circle to represent the nucleus. The nucleus contains 2 subatomic particles, protons and neutrons. Therefore, we will write 15p and 16n inside the nucleus nucleus to represent 15 protons, P for protons, and 16 neutrons, N for neutrons. Now it's time to start arranging the 15 electrons on the shells of the phosphorus atom following the 4 electron arrangement rules. Before we begin, note that we can use either a dot or a cross to represent the electron. For this lesson, we will use the dot. So after representing the number of protons and neutrons in the nucleus, the next step is to follow the electron rules to draw the shells containing the electrons around the nucleus. Let us do a quick recap of the rules. The first shell holds a maximum of 2 electrons. The second and third shells hold a maximum of 8 electrons each. The fourth shell, a maximum of 32. And of course, the lower energy levels must be filled with the maximum number of electrons before drawing the next shell for electrons. Since we have 15 electrons to be placed or arranged on the phosphorus atom, the first thing we do is to draw a concentric circle surrounding the nucleus to represent the first energy level or shell. From this point, we'll just call them shells. Now, the first shell can hold a maximum of 2 electrons. Since there are as many as 15 electrons to be arranged on the atom of phosphorus, we can safely draw the maximum 2 electrons on the first shell. And we always place the electrons maximum distance away from each other. Now, this leaves a balance of 13 electrons to be arranged on the atom. Since the first shell has its maximum of 2 electrons and we still have a balance of 13 electrons to be arranged on the atom, we then draw a second shell. The second shell can hold a maximum of 8 electrons. Now, since 8 is less than the 13 electrons we have to arrange, we can place the maximum number of 8 electrons on the second shell. Note, when filling the second shell, we place the first 4 electrons at a maximum distance apart, then pair them to complete the 8 electrons. At this point, we have arranged a total of 10 electrons, 2 on the first shell and 8 on the second shell. As a result, we still have 5 electrons of the 15 to be placed on a shell. Once again, since the second shell is full, that is, it contains its maximum number of electrons, which is 8, and there are still 5 electrons yet to be arranged, we can draw a third shell. The third shell, as we know, can hold up to 8 electrons. Since we only have 5 electrons remaining, which is less than the capacity of 8 electrons, we can draw all 5 electrons on the third shell. Once again, place the first 4 electrons at the maximum distance apart, followed by pairing until all 5 electrons are on the shell. You may have noticed the electron configuration popping up on the screen as we arrange the electrons on the shells of the atom. This notation indicates that there are 2 electrons on the first shell, 8 on the second shell, and 5 on the third or last shell of this atom. We often use commas or sometimes full stops, also known as periods, to separate the quantity of electrons on each shell. The drawing of the phosphorus atom is now complete. So the phosphorus atom, as we see, has 3 shells, 1, 2, 3, with 5 electrons on the last shell or the third shell in the case of phosphorus. We can use this information to identify the position of phosphorus on the periodic table. Let us take a quick look at the periodic table. Here we see that the elements are arranged in columns. We see a number of columns there with all the symbols and names of the elements. And of course, these columns are called groups. And they're also arranged in rows, and we can see the rows going across, and these rows are called periods. So it's important to keep in mind that the columns of elements in the periodic table are called groups, and the rows of elements in the periodic table are called periods. Also take note that the groups are numbered 1 through to 7 and 0. So we have group 1, group 2, group 3, so on, right over to group 0. And we have written the group numbers at the top top of each group or column. Now, the periods or rows are also numbered as written to the left side of the periodic table. The first period consists of hydrogen and helium. The second period starts with lithium and ends with neon. The third period starts with sodium and ends with argon, and so on, moving from left to right. Now, the group and period numbers give vital bits of information about the atom. The period number corresponds to the number of shells that the atom has. Therefore, hydrogen and helium, which are in period 1, will each have one shell. Likewise, all the atoms of the elements of group 2, that is from lithium all the way through to neon, will each have 2 shells, and so on. The group number, on the other hand, indicates the number of electrons on the last shell of the atom. So all the atoms of elements in group 1 will all carry 1 electron on their last shell. The same happens with group 2. All the elements in group 2 will have 2 electrons on their last shell, and so on. The only exception is group 0. The value 0 simply indicates that all the atoms in the group have the maximum number of electrons on all their shells. Since an atom of phosphorus has 5 electrons on the last shell, it's therefore found in group 5 of the periodic table. And since there are 3 shells, then it's located in period 3. Let's see if we can find phosphorus in group 5, period 3. So this is group 5, and this is the first period, second period, third period, and there it is. Phosphorus. The next practice drawing will be that of lithium, symbol Li, and uppercase L and a lowercase I. In some jurisdictions, they say capital L followed by a common I. Lithium has a mass number of 7 and an atomic number of 3. Since lithium's atomic number is 3, then lithium has 3 protons as well as 3 electrons. The number of neutrons, we calculate that by subtracting the atomic number 3 from the mass number 7, which gives 4 neutrons. Now it's time to draw the lithium atom. First, we draw the circle that represents the nucleus, then we record the number of protons and neutrons in it. Lithium has 3 protons, 3p, and 4 neutrons, 4n. Next, we arrange the 3 electrons on shells. Therefore, we draw the first shell. The first shell holds a maximum of 2 electrons. Since 2 is less than the 3 electrons to be arranged, we can put the maximum 2 electrons on the first shell. After placing 2 electrons on the first shell, there is still 1 of 3 electrons remaining. Since the first shell has the maximum number of 2 electrons, and we still have a balance of 1 electron to be placed on a shell, we can go ahead and draw a second shell and place that 1 electron on the second shell. So the drawing of lithium is now complete, and it has an electron configuration of 2, 1, 2 electrons on the first shell and 1 on the second shell. So an atom of lithium has 1 electron on the last shell, which means it's located in group 1, and because it has 2 shells, we know it's located in period 2. Let's do a quick check of the periodic table to see if lithium is in that precise location. So we go to group 1 and count down 2 periods. So we go 1, 2 periods. Here it is, lithium. The third practice drawing is that of hydrogen, symbol H and uppercase H. Hydrogen has a mass number of 1 and an atomic number of 1. Since the atomic number of hydrogen is 1, then hydrogen has 1 proton as well as 1 electron, since the number of protons and electrons are equal in an atom. The number of neutrons is calculated by subtracting the atomic number of 1 from the mass number 1, which gives 0 neutrons. To draw an atom of hydrogen, first we draw the circle to represent the nucleus and record the quantity of protons and neutrons in it. 1 proton and 0 neutrons. There is only 1 electron to arrange on the atom, so we draw the first shell and place the 1 electron on that first shell. There are no more electrons to be arranged, so the diagram of hydrogen is complete. As a result, the electron configuration of hydrogen is simply 1. 1 meaning there is 1 electron on a single shell. The final practice drawing will be that of calcium. The symbol for calcium is an uppercase C followed by a
a lowercase a. Calcium has a mass number of 40 and an atomic number of 20. Since the atomic number is 20, the atom has 20 protons and 20 electrons because the number of protons and electrons are equal in an atom. The number of neutrons will be the atomic number 20 subtracted from the mass number 40, which gives 20 neutrons. We will take a different approach to drawing the atom of calcium, however, using the same electron arrangement rules. We will start by locating calcium in the periodic table. Calcium, as you can see, is located in group 2 and period 4. Once we know the location of calcium on the periodic table, as we can see, it's in group 2 and period 4, we can now go ahead and draw the atom. As usual, we will start with drawing the small circle for the nucleus and filling in the number of protons and neutrons, 20 protons and 20 neutrons. Since calcium is located in period 4, it has 4 shells. So we will draw 4 concentric circles of progressively larger diameter around the nucleus. 1, 2, 3, 4 shells. Calcium is in group 2. Therefore, there are 2 electrons on the last shell. So we'll draw those 2 electrons on the last shell, which is the 4th shell in the case of calcium. For the 4th shell to have electrons on it, this means that all the inner lying shells, 1, 2, and 3, contain their maximum number of electrons. Following the electron arrangement rules, we will draw 2 electrons on the first shell, 8 electrons on the second shell, 8 electrons on the third shell. As a result, the electron configuration for calcium is 2, 8, 8, 2, which means there are 2 electrons on the first shell, 8 on the second and the third, and then 2 on the last shell. Let us check to ensure that all 20 electrons have been arranged on the atom. 2 on the first plus 8 on the second gives 10, plus 8 on the third gives 18, plus 2 on the last gives a total of 20 electrons. As a result, we can say the diagram of calcium is complete. We have learned quite a bit in this lesson, so let's do a quick summary of some of the important points. First, the mass number is the number of protons plus the number of neutrons. The atomic number is the number of protons. On a standard periodic table, the mass number is written to the top and the atomic number is written at the bottom of the symbol of the element. In an atom, the number of protons equal the number of electrons. To find the number of neutrons, subtract the atomic number from the mass number. The electron configuration tells how the electrons are arranged on an atom. When drawing an atom, the first thing, draw the nucleus, then record the number of protons and neutrons within the nucleus, then arrange the electrons on shells following the electron arrangement rules. Note that the number of shells of an atom is equal or is the same as the row number or the period number in the periodic table. Also, the number of electrons on the last shell of the atom is the same as the column or group number on the periodic table. It's quiz time and you have 5 seconds to answer each question after it is read aloud. Question 1. Which information is given by the atomic number of an atom? A, the number of neutrons, B, the number of protons, C, the number of protons and neutrons, D, none of the above. The answer is B. The atomic number gives the number of protons of an atom. Question 2. How many neutrons are present in the atom shown on the right of our screen? A, 56, B, 26, C, 82, D, 30. The answer is 30. To find the number of neutrons, we subtract the atomic number from the mass number. So that's 56 subtracting 26. That gives us 30. Question 3. How many electrons does an atom of carbon have? A, 12, B, 18, C, 6, D, 8. The answer is C, 6. As we know, the atomic number gives the number of protons, but for an atom, the number of protons equal the number of electrons. So there will also be 6 electrons in an atom of carbon. Question 4. Silicon is located in period 3 and group 4 of the periodic table. What is the electron configuration for silicon? A, 284, B, 283, C, 2883, D, 2884. The answer is A, 284. Silicon being in period 3 would have 3 shells, and the last shell would have, or the third shell would have 4 electrons on it since it's in group 4. So we know the last digit for the electron configuration of the 3 shells must be 4, and the other 2 shells would have only a maximum number of electrons, where the first shell has a maximum of 2 and the second shell has a maximum of 8. Question 5. The atom beryllium has a mass number of 9 and an atomic number of 4. Which diagram below gives the correct illustration of the atom? A, B, C, or D? The answer is B. Since the atomic number is 4, then there are 4 protons in the nucleus of the atom. We find the number of neutrons, 5 neutrons here, by subtracting the atomic number 4 from the mass number 9, which gives us 5 neutrons. Now, if there are 4 protons, then we know there are 4 electrons on an atom of beryllium. We place the maximum of 2 on the first shell, which means we still have 2 remaining, and we place those on the second shell. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.